Thank you. No, thank you very much. Thank you, everyone at Saventrix, for inviting me to have a little chat about the sector that I'm very passionate about, and I really am. To give a tiny bit of context, I've been in this trade for nearly 28 years now. Straight from college, I started my career at Norwich Union assessing insurance claims for damage, septic tanks, treatment plants, and cesspits. So this is literally all I've ever done. So I'm dreadful in a dinner party scenario, but hopefully for a presentation on this very subject matter, I might be quite useful. So I'm just going to dive in, if I may. So thank you, Ian, for giving us a summary. This is primarily about the general binding rules. They are now 11 years old. Um, and just before we go into it, I just wanted to do a very quick refresher. Obviously, I don't know if anyone has seen a presentation from me before. I don't know how involved you get in the private off-mains drainage world. But for the benefit of everyone here today, I'm going to do a quick overview of the size of the sector, the different systems, why they fail, how they fail, then the different rules and regs that cover my world, and then we'll put that all together with an overview of the general binding rules at the end. So first and foremost, the all this data is from the Office for National Statistics, and on their very website, they state that year on year, because of the decline in responses to their surveys, they can't be accurate on their numbers, but this is all we have to play with, so it's a good starting point. And it doesn't actually specifically reference my world. It references the world of properties connected to main sewerage, of which it says there's 95% of the 32 million housing stock in the UK. So if we reverse engineer that, we've got 5% to play with, which translates to 1.6 million properties that are served by private off-mains drainage systems. And at the bottom right there, you see the breakdown per country. It's there or thereabouts. It's never going to be beautifully accurate, but it is quite a large number. And therefore, there are lots of opportunities for non-compliant systems to be discovered and rectified for the good of the client and the wider environment. So, what are private off-mains drainage systems? There are only three: cesspits, sewage treatment plants, and septic tanks. Cesspits are just huge, watertight holding tanks installed underground. They take all the grey and foul water from a property or properties, if it's a communal setup. It gets to the top and it needs to be emptied. There is no science involved whatsoever. They're holding tanks, they fill up, they need to be emptied. The issue with cesspits is that they are very large, so they need a large footprint in a property to install. They're expensive to purchase and they're expensive to maintain. And when I say maintain, it's really just the emptying cost that can really hurt the pocket. And the example we've got here is just a basic one from a builder's merchant. It's one of the smallest ones you can purchase, 38,400 litres. It's good enough for a 3-bed house. That, to get it in the ground, is going to cost in the region of £35,000. And if it's sized appropriately for the property it serves, you'll have to empty that between 6 and 8 times a year. And with the emptying costs from these big vacuum tankers that come along and suck out the waste, it can be up to £800 an empty. So it really does get very expensive very quickly. Now, from a domestic setting, these are going to get phased out, I'd say, over the next decade, because it's extremely hard to get them signed off. And what I mean by that is, if we were to try and get one in the ground, the environmental regulator and the local building control officer would want to see evidence that we can demonstrate that we've tried every other drainage provision first, such as connecting to main sewer, discharge into ground via a soakaway arrangement, discharge into a surface water for treated effluent from a treatment plant. And only if you can demonstrate that none of those options work, you will have a chance of installing a cesspit. The reason why they're not particularly well liked is that if ever there is a structural breach within the base or the walls of this asset, you've got a huge volume of untreated wastewater going straight to ground. If it hits an aquifer, finds a surface water, it can be a pollution event very quickly. So yes, it's still a legal provision of drainage, but they will be phased out over the next 10 years or so, purely because they're so hard to get sanctioned. Um, in a scenario of campsites and similar dynamics, you get very small cesspits and they're never going to die away simply because they're perfect for chemical toilets. When you have the blue chemicals added, they're great for those. So from a campsite dynamic, they'll always be around, but from a domestic residential perspective, they're going to be phased out. And also cesspits, first mistake with the general binding rules, cesspits are not covered by the general binding rules because the full title of the general binding rules is the Small Sewage Discharge General Binding Rules. And with a cesspit, there is no discharge, there is no exit, there is no outlet pipe. So only septic tanks and sewage treatment plants are covered under the general binding rules. There are, of course, regulations that cover sizing of cesspits, how they're installed, how near they are to any habitable part of a dwelling, but cesspits are not covered under the general binding rules. So we've gone, in my opinion, from the least environmentally friendly, being a cesspit, to now the most environmentally friendly, and we're now looking at a cut through of a sewage treatment plant, or referred to also as a package treatment plant. They're one and the same thing. Effectively, this is, if we were to go back 60, 70, 80 years, if a property had the Rolls-Royce wastewater treatment system, they would have a separate septic tank, then some sort of filter or clinker bed, then a reed bed, and then it would be allowed to discharge into a free-flowing surface water. What we have in front of us, housed in one shell, are all those component parts. So the first compartment, or to give it its correct label, the primary zone, is in fact a small septic tank within a sewage treatment plant. So all the foul and grace water come into the primary zone. In periods of calm where we're at work or we're asleep at night, something called anaerobic digestion occurs, which is effectively natural separation. So all the dense matter will fall under gravity to the bottom to form the sludge layer, and everything that floats, so fat, oil, grease, rags, tissue, will rise to the top and form a crust or a scum layer. And the section in the middle, although it won't be particularly clean to look at, with those nasties removed, it's called clarified liquor. So it's nothing more than slightly cleaner water than when it came in, but the big deposits have been retained inside that primary zone. So that clarified liquor, when it hits a certain height within that primary zone, under gravity, it trickles into the second chamber, which is called the treatment zone. And this is where there will be either little plastic or composite pellets called media, where the good bugs, the microorganisms, they stick to these media. They deal with any pollutants that have come into the sewage treatment plant, but they need the same to survive and then thrive. They need food, water, and oxygen. Food and water is provided by what we've put into the primary zone. But you'll see on top of that illustration, you've got that blower unit, and that is working 24/7, introducing oxygen into that zone. So it gives it the perfect conditions to thrive and deal with whatever we put into it. Again, once the liquid level hits a certain light in that treatment zone, under gravity again, it trickles into what's called a final settlement zone or final settlement chamber. And that allows any suspended solids that have somehow got through those first two chambers, it's the last chance to capture it and retain it. So the only thing that leaves a sewage treatment plant is treated effluent. It will be colorless and odorless, but it won't be 100% pure water. So you can't use it for anything. You can't even put it on the flowers in the back garden. But it will be between 95 and 98% pure water, or to flip that around, 95 to 98% of pollutants will be dealt with within a sewage treatment plant. Now, the reason why it's the most environmentally friendly is because what leaves a sewage treatment plant is very, very clean. And it also gives the asset owner a lot of options for legal discharge. So a sewage treatment plant can legally discharge to a free-flowing surface water, a seasonal surface water, a conventional soakaway, borehole soakaway, an above-ground drainage mount. It really does give a myriad of options. Some of those don't need a permit, some of them do for the discharge, but all of them are legal discharges. Like anything such as our motor vehicles, a sewage treatment plant needs to be looked after. It needs an annual service. An annual service not only ensures that it's working correctly, which means that the quality of the effluent maintains at a high level, but it also makes sure that the manufacturer's warranty remains valid. A lot of UK manufacturers state that even though their warranties are between 20 and 25 years respectively, some of them are very, very harsh. If one service has been missed, they don't have to stay true to that total length of the warranty. So it's important for the longevity of the warranty and to ensure that the system works. So service costs about 150 to 180 pounds. If it needs to be emptied at the same time, you could add another 150 on top. You're going to be looking at between 70 and 100 pounds for the electricity for the constant use of the blower box to feed oxygen into the system. So yearly, you could be looking between £450 to maintain a sewage treatment plant. And the way I remember that is it's similar cost to sewage rates if a property is connected to the main sewer. That's how I remember it anyway. What we typically find, though, even though sewage treatment plants will be the thing that serves most properties, I reckon over the next, as cesspits phase out, sewage treatment plants will become as popular as cesspits become unpopular. But still, the vast majority of assets in the UK are still septic tanks. A lot of them are what we're looking at now, the older style, which would have been made of brick, blockwork, or concrete. The modern day ones are glass reinforced plastic, MDPE, any sort of strengthened plastic is normally the material of choice. But what we're looking at here, and the reason why it's on the screen now, is just to give an example of what happens in a septic tank. So there are no moving parts. There is no treatment that occurs in a septic tank. The treatment happens when it hits the soakaway on the back end of a septic tank. But it's interesting to see what they are and how they work. Now, septic tanks can be 1, 2, or 3 chambers in sequence. And effectively, the more chambers you have, the slightly cleaner the water will get as it travels through. We have got a very traditional 2-chamber septic tank that we're looking at now. The vast majority are 2 chambers. And it's so important that they are 2 things, that they are sized appropriately and that there's no rainwater cross-connected. And that's because septic tanks work by hydraulic displacement. So if we introduce 100 litres into the septic tank, it has to push 100 litres out the back end. If the septic tank is too small for the property it serves, it means the correct separation process wouldn't have been allowed to occur. So when 100 litres are being pushed out, instead of it being the clarified liquor, there will be lots of solids mixed up with that being pushed out. And the negative side to that is that if it's connected to a soakaway, it will start to block up the holes in the substrata and it will start to exhaust and choke the soakaway, and it's the start of the failing process. Or worse than that, if the septic tank is illegally discharging into a surface water pollution event. Similarly, if you've got rainwater cross-connected to this septic tank, in periods of sustained rainfall, you create like a churn effect. Think of it like a washing machine. The constant water agitates everything that's inside that septic tank, not allowing it to separate and fall to the bottom, right to the top as it should, meaning that it will just everything in that 2-chamber tank will get pushed through and again either negatively impact the soakaway or pollute the watercourse that it's illegally connected to. So it's so important they're sized appropriately with no rainwater connections. Very, very quickly, I'm not in any way associated to any UK manufacturer, but it is a fact that in 1965, Clargester introduced the first glass reinforced plastic tank, which is what we're looking at the left-hand side of the screen. It's often referred to as an onion tank purely because of the shape, but it's actually called an alpha tank. Not that anyone cares apart from me, but that's what it's called. That was introduced in the UK in 1965. Really clever design, cheap to make, robust, quick to install, very, very clever design. The only issue was if you look in the middle of that septic tank, you'll see that lampshade type object in the middle. That's called a conical baffle. And that's to prevent the fat, oil, and grease rising above that level to be able to exit the tank and communicate with the soakaway. The issue was That baffle was held in place by four hooks attached to the turret or entrance neck of the septic tank. And most times that the emptying hose was put into the tank, it would knock one of those hooks off. The baffle would fall out of its original horizontal position. Fat, oil, and grease would then be allowed to rise above it, exit the tank, and it would start the failure process on the soakaway. So within about 5 or 6 years, we're now looking at the right-hand illustration. This is the Generation 2 Alpha tank, where the conical baffle was welded in place between the two halves of the spherical part of that tank, and they are almost bulletproof. A lot of the pre-purchase surveys that my guys carry out are still looking at these Generation 2 tanks put in from the 70s, 80s onwards, and they're absolutely fine. And we normally find that the tank is absolutely fine, but it's on its second or third soakaway. That's typically what we find. So I'm glad we're not going to look at these pictures over mealtime because some of them aren't particularly lovely. But as you can see on the left-hand side, I'm not going to do death by PowerPoint. There are a myriad of reasons why these tanks can fail, or the systems fail. They can be. Unbelievably, some of these tanks are put in back to front, even though the manufacturers in big letters on the assets say in and out, they can still be installed back to front. They can be installed on the wonk, so they're not level, and that affects flow. They could have the wrong backfill material, so if the water table rises, it can make them wobble and move out of alignment. They might just damage over time. They might be coming to the end of their natural life. There could be external factors like hydrostatic pressure, tree root damage. That honestly, there are so many. There's just a few on the left-hand side, but typically you can't tell what the problem is until you've had a thorough inspection, and that's not a sales pitch whatsoever. It's just a fact. Surveyors can get a good feeling on what the system is, where it might flow, where the discharge is, but sometimes it does need specialist firm to come in with the right equipment and really get to grips with what the system is, how it's performing, where it's discharging to, is that discharge performing, and is it legal? And what we've got here, this is a really good one, and apologies if anyone's seen this on LinkedIn, I am repeating what I put out there. A really good indicator that if a septic tank is working as it should is an immediate gauge on the liquid level inside the tank. So what we're looking at is the exit pipe. We're in chamber 2 of a 2-stage septic tank. And what we should be looking at is the liquid level hovering at 6 o'clock on that clock face. That means it's just above the outlet pipe, meaning it's getting away. If the liquid level is below 6 o'clock on a clock face, it means there must be a structural breach within the tank walls, which is allowing the contents to get that liquid level reaching the required height. On the flip side of that, we are looking at the reverse, which is a surcharge tank. We're a few inches above that perfect 6 o'clock level, and that tells us straight away that something is preventing the travel of that liquid getting out of that tank. At this stage, no one knows why. It could be tree roots, it could be a minor imperfection in the tank, it could be a soft blockage, a build-up of tissue, or it could be something more fundamental, which is the soakaway's come to the end of its life, and this is causing a surcharge effect. To add a couple of details to this specific site, our chaps noted that the whole garden area was extremely boggy underfoot. There were wet patches on the ground level, and if you imagine driving on a rainy day and you see that rainbow puddle effect, you get that in a garden where the surcharge ground has breached the ground level and it just sits on top of the lawn, and that's what you get. Also, if you have a lovely, well-kept garden, but there's an area of stinging nettles, that might just be that it's a lot of stinging nettles, or it might be that there's high ammonia readings in that subsoil around that area of nettles. And that's because nettles love ammonia. So again, it might not mean there's a failure, but it's just little things to look out for, potential red flags as to what's going on. In this situation, the full story is that it was a failed soakaway. The whole thing was completely exhausted, and we had to put a new drainage field in to serve this septic tank. A massive problem in my world, and indeed every drainage firm's world, is tree roots. They are unbelievably clever. It's a fibrous root. 50 meters away from the tank. It's attracted to a bead of moisture created by the difference in temperatures inside and outside the pipe. It can be drawn to a hairline crack. The root can get in that crack, make it bigger, and then it grows inside the pipework because it's absolutely perfect nutrients and growing environment for them. This is more of half of a tree rather than normal tree roots coming through the pipework. Luckily, this was physically extracted. There was only one point of entry about 20 meters down, very small minor pipe repair, and it was back normal. But as you can see, this tank clearly hadn't been looked at in years because this is more than 1 year's growth of roots. Apologies for the picture, it's the best I could do. This has taken a digital still from a camera survey. We're now in the outlet pipework from a septic tank going to a soakaway, and this is 100% root mass that we couldn't pass. We put a cutter through it, it wouldn't touch it. It was completely sodden behind it as well, so we had to put a new drainage field in again. Just a problem we come up against and what we find with our camera equipment. What we're looking at here is a beautiful example of land drainage. We're looking at ribbed pipework, 4-inch in diameter. And if you've seen this before, you've got loads and loads of mini perforations around the entire circumference of the pipe. Problem is, this pipework was serving a septic tank as a soakaway. So this is incorrect pipework for drainage. Drainage field pipework only has slots or perforations at the bottom of the pipe, designed to serve the septic tank wastewater that it receives and slowly and calmly let it release through those slots and holes underneath the pipework where there is clean stone, there's good bacteria growing on the stone, and that's where the treatment occurs. When you put in ribbed land drainage serving a septic tank, you are knowingly attracting all the groundwater into the pipe because that's what land drainage ribbed pipework is for. You put it in a farmer's field, you draw the water in, and then you take it away in a controlled fashion, normally to a ditch or any other surface water. So this is why this customer's soakaway failed, because it was taking all the water from the surrounding area. A massive problem, as I alluded to with the cutout drawing of the septic tank, is rainwater cross connections. Of every survey we have ever done on cesspits, septic tanks and sewage treatment plants, 35% of them have rainwater cross-connected. Not necessarily the entire roof space, but certainly at least one downpipe going in. My engineer, Pete, had the customer behind him on this scenario saying, no, 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 no rainwater is going in. And we said, well, okay, there's the gully to the downpipe. There's the 20 centimetre gap to the manhole, and the septic tank is 5 meters away out of shot. So that was our proof via dye that it's got a rainwater cross connection. They must come off. A lot of customers think we're being pedantic. Not at all. It ruins the separation process in a septic tank. It ruins the treatment process in a sewage treatment plant. So even if the customer puts a water butt on, that's absolutely fine, as long as that rainwater is not entering the foul system. So important that all of it come off. And this is just one side of a septic tank. I could have done a 360 and it would have been similar damage all the way around. The level was never reaching the outlet pipe height because of these massive fractures in the pipe in the side walls. Sometimes it can look worse than it is, and it's just the blown render rather than a structural problem. But this was fractured all the way through the render, all the way through the brickwork, and all the contents was just getting out. So unfortunately, it was beyond economical repair, and we had to put in a brand new system for this customer. And this is an absolute classic. And apologies again, I do use this picture a lot, but I just like it as a great example of what can happen and just how powerful water retained in the ground is, hydrostatic pressure to give it its correct label. What we should be looking at on this treatment plant is that green lid on top should be the only element of that sewage treatment plant that we can see from ground level. So it should be sitting about 2.5 inches proud of the ground. What we're looking at here is the whole treatment plant 2 meters proud of ground level. And what happened here, in the old days when I actually worked weekends and put a shift in, I took a call from a customer Saturday morning. She had had her sewage treatment plant emptied the Friday afternoon, the day before. She opened her blinds, had her morning coffee, looked out in her back garden and saw that. She phoned up and said, I'm not an expert, but I don't think it's right. Yes, she's correct. That's not right. What's happened here, we refer to it as a pop tank. Anyone can come up with a better label if you wish, but effectively, it's a specific dynamic that happens a hell of a lot. We get one a day in heavy weather. The tank is emptied. The customer, the empty engineer, do not appreciate at that moment in time the weight of the contents is the only thing holding that tank in the ground. What we've got, even though that sewage treatment plant will weigh circa 400 kilos, which is which is quite a lot of weight, against the power of hydrostatic pressure, it's got absolutely no chance of surviving. So what happens is, because it's built of a similar material to that of a hull of a boat, it wants to float. So it doesn't need much encouragement. Now they either come upwards and start the popping process, or the walls will start to cave in, or the base will start to implode. They're the three things that happen on this one. The asset has remained whole, but it's popped up. I've seen an example worse than this, where it physically popped out the ground and came to rest next to the excavation hole. So that's how much power there is. In this situation, unfortunately, on the reverse of that treatment plant, there's a lot more damage. We couldn't do a glass fiber repair, so this was a 20,000 replacement. These only have to rise by about 1.5 inches, 2 inches for the alignment to be negatively impacted on the incoming and the outgoing pipework. If they come out of alignment and snap from their fittings, then everything from the property isn't going to go in the treatment plant. It's going to hit the side, the external side wall, and then run underneath it. So there will be a horrible brown lake underneath that sewage treatment plant. So it's absolutely critical, even though, yes, you should get these emptied regularly. If it's after heavy sustained rainfall, let it dry out a bit. Don't get it emptied. Leave it 6 weeks, 8 weeks. That's what we tell customers. It's not going to be the end of the world to leave it a couple of months extra, because it's a lot better to do that rather than come up with £20,000 for a brand new treatment plant. This customer's insurance company covered it, thankfully, but not all insurers do. Okay, so these are the documents that rule my world. And I'm sure, apologies if I'm preaching to the converted, but Building Regs 2010 Part H, Section 2 specifically covers private off-mains drainage, the materials to use, where to site them, etc., etc. The BS 6297 2007 is a 46-page document all about drainage fields, how to do the percolation tests, how to look for how to introduce the parameters of where to install drainage fields, how to install them on sloping sites. I think it's fascinating. You might not, but it's a great read. It sends me off to sleep anyway. British Water Flows and Loads currently on their 4th edition. That tells us exactly how to calculate the size of a plant, whether it's for a domestic or commercial setting. The BRE 365 is the guidance document for soakaways, percolation tests and soakaways for stormwater. So when we're dealing with rainwater cross connections and we can't do a quick fix of a water butt, we have to do a percolation test as per that BRE. The BRE 478 is another guidance document for above ground soakaways, so drainage mounds. Huge, expensive, purpose-built mounds or hills in the back garden, in a field, wherever it may be, for where you haven't got great porosity in your subsoils. Crazy expensive, but more than you think get installed. And then the hot potato, even though we're still 11 years on after its release, is the small sewage discharge general binding rules. And if I may, I'm going to take a few minutes to talk about what they are. So, contrary to what the internet says or what I hear on a daily basis, the general binding rules were not introduced in January 2020. They were introduced in January 15. And the confusion stems from when they were first released, there was a line in the sand drawn for 5 years, which would have taken us to January 2020. The idea is in those 5 years or 60 months, as they kept referring to it, every single septic tank was supposed to be assessed. And if they were found to be non-compliant, they were supposed to be addressed in that 5-year period as well. As we all know, that simply didn't happen for a number of reasons. There's no database in England to send proactive marketing and literature to tell the asset owners about this new regulatory reform. There was no decent amount of publicity to property professionals, whether it's building surveyors, conveyancers, property surveyors, estate agents, portfolio managers, estate managers. The information just wasn't out there early enough, or when it did come out, I don't think it came out with sufficient guidance notes to appreciate how it's going to be implemented. Um, the catalyst for the release of this regulatory reform was to stop septic tanks discharging directly into surface waters. Now, although there are no actual numbers to confirm how many there were or are doing this, we believe it could be anything up to a couple of 100,000 septic tanks doing this, simply because it was the done thing all those decades ago. It didn't really matter that much. Before the invention of the Environment Agency, the Rivers Authority had jurisdiction over this, and there wasn't really a great deal of guidance back then. So, yes, it happened in great significance. It doesn't get the negative PR that the water companies get when they have a sewage spill. But if you were to add up all these individual domestic spills, times 100 or 200,000, it would be equal to these nasty spills. But it doesn't get the press because we're looking at individual spills. So what we're dealing with is a fantastic initiative. Although we're 11 years on and this 5 year guide time frame hasn't worked, what has worked is the awareness is there now. Every surveyor I speak to knows about it, at least to a decent level to get them out of trouble. Conveyancers, property solicitors, they're getting it. We notice it with mortgage lenders now. Most of them require a certificate of compliance before they proceed on the transaction. So it's only really cash purchases where there is a more relaxed attitude. It's a shame, but there's no way of forcing the situation. So it's where a lender is involved, we seem to be capturing every single non-compliant discharge, which is a whole point of this initiative. So I'm not going to run through all the rules. That'd be mega boring. There are 23 rules that make up the general binding rules. 1 to 14 are applicable to any off-mains drainage system with a discharge. Rules 15 to 21 are applicable to any new discharge installed after January 2015. And then rules 22 and 23 were introduced in October 2023, and they're to do with not allowing a foul discharge to be near a stormwater discharge. It talks about having a minimum distance between the two, how they can discharge, where they can discharge. So altogether, an excellent set of rules. All we've done is take the rules from the government's website, we've stuck it in an Excel form to create a checklist, and we've issued that a few thousand times already. And it means that even customers can start walking around the property and get a gauge of what these rules are, how their system applies. Do they think they might have a problem? They're never going to know without a specialist survey, but at least it creates awareness. So it is a fantastic initiative. The part of the rules that often gets forgotten and causes some issues is because we never refer to the general binding rules by its full title, which is preceded by small sewage discharge, we sometimes look or sometimes miss vital information. So again, preaching to the converted, I'm sure, but the general binding rules, from my perspective, is the equivalent of self-certification. So if you have a system that's discharging to ground, if you're discharging less than 2,000 litres per day, you are within the confines of the general binding rules and you're compliant. You don't need to go for a permit. On the flip side, if you're discharging to a surface water, you're allowed to be discharging up to 5,000 litres per day without the need of a permit. So if you know how to calculate usage, then you can do a quick calculation. It's on a government website. We have a calculator we can issue, but effectively it's really rudimental, and it doesn't matter that I don't necessarily agree with it because this is what we all have to work to, irrespective. So it works on the basis of potential maximum occupancy of a property, not actual occupancy, it's maximum potential. And the way that is calculated is very simple. If we're looking at a 3-bedroom property, it's number of bedrooms plus 2. So a 3-bedroom house has a maximum potential occupancy of 5 persons. We allegedly use 150 litres per person per day. So 5 times 150 gives us 750 litres maximum daily discharge for a 3-bedroom house. If said 3-bedroom house is served by a septic tank and is discharged into a soakaway in the back garden, so it's a ground discharge, then that is compliant with the general binding rules. What we're not saying in the scenario where you've got 3 properties and you have to add them up as 3 times 750, so we're just over the 2000 limit, it's not in any way illegal or it's not in any way a problem. It just means that you need to make a formal approach to the Environment Agency if this is in England. You have to explain the situation, demonstrate how many bedrooms you got, give your postcode, and then the permitting officer that's assigned to the application for the permit to discharge will take a quick look. And when it's just over 2000, and if we're nowhere near a protected site or a triple SI, we're nowhere near a surface water, there's every chance the Agency will send an email back saying, under these specific circumstances, this doesn't need a permit. And that's fine. And then the asset owner has an audit trail to say that they've done the right thing. They've made the approach, they've had the feedback from an EA representative, and this doesn't need a permit. Fantastic. The issue with exceeding 5,000 litres going to a surface water is that whether it's serving a domestic setting or not, the Environment Agency class an excess of 5,000 litres a day as a commercial discharge. So whereas an EA permit for a domestic setting will be in the region of £180, for a commercial discharge, they are bespoke fees. And to put that in context, the last one we did was a care home in Stoke, and the initial fee was £6,800. And then there was an annual fee of £2,200, which allows sufficient money for a representative to go out and take samples to ensure the quality of effluent was A-OK. So the difference in price is absolutely huge. So again, if you exceed the daily volume, it doesn't mean you're doing anything illegal. It just means that you do need to make that formal approach and get the feedback of the Environment Agency and roll with the punches of what they tell you to do. You can't go around them in any way. Um, so the big hitters for non-compliant system, those 23 rules that make up the general binding rules are really good. Some of them seem really minor, and you think not the end of the world. Some of them are massive and obvious, such as the first one, the very reason this regulatory reform was built. It's to prevent septic tanks discharging to surface water. But the general binding rules is more than that. It specifically says about a system can only be compliant if it's performing as expected. So dig into that a little deeper. If you've got rainwater cross connections, it can't perform because every single UK manufacturer stipulates in their brochures that no rainwater can connect to the FOW system. So that's why I am repeating about the importance of getting rid of rainwater coming into FOW systems, because they disrupt the separation or treatment process. So if you've got rainwater cross connections, that is a non-compliant system. If you stick in a couple of water butts and physically prevent the cross connection, then that flips to a compliant system straight away. That's how quick and easy it can be from non-compliant to compliant. One thing that was introduced when 2020 came and went, and we thought, what on earth's going to happen now? Because only a tiny proportion of these septic tanks have been looked at. There's a couple of little lines that were added to the government website, and the one about 12 months is really important. So, for example, in a dynamic of a property transaction, and whether you guys or us or someone similar to me finds a septic tank illegally discharged into a surface water, the government website states that a fair and reasonable time frame to address that non-compliant discharge is 12 months after discovery. Now, in a dynamic of a transaction, it's extremely unlikely that the vendor and the purchaser are going to wait 12 months. So clearly, we need to bring that forward. And another line that was added to the rules is that a non-compliant system, specifically a septic tank discharge into a surface water, it needs to be addressed as a condition of sale. So that's fantastic. So we've now, every stakeholder involved knows about the rules. They know a base knowledge, so nothing can slip through the net. We know that we've got a 12-month countdown, but more importantly, we know that this has got to be captured within the documentation of this transaction. The only fly in the ointment, from my perspective, is that the website and the guidance doesn't go further than condition of sale. And what I mean by that is it doesn't say whether the vendor and the purchaser should pay an equal contribution each. It doesn't say if the vendor is going to have to physically get the work completed pre-exchange. It doesn't say if the specific amount of money should be held in a separate client account, ready for the new owner to come in and then get the work carried out within that 12-month time frame after they've taken ownership. But at least it does the most important element, which is raised awareness, it's captured a non-compliant system, and by hook or by crook, during that property transaction, there's going to be works or monies retained for a compliant system to be installed. So that is mega important. And that's why it's so important that property transactions are by far the most common way that non-compliant systems are discovered and then addressed. So us in the room now, in your respective rooms, we are the people to really push this forward for protection of our clients and the environment. Again, not death by PowerPoint. If I may go straight to the penultimate bullet point, this is the one that really is naughty. And what I mean by that is, whether it's done on purpose or not, there are so many new systems. There's so many people being ripped off because of this 1983 line within the General Binding Rules. 1983 was the year the first British standard was introduced regarding treatment processes and treatment systems. So it has been deemed extremely unfair for a system that was installed before 1983 to somehow magically adhere to rules and regs that were released after 1983, which is a fair comment. But what I mean by unfair, and where cowboy contractors really, really take advantage of this, is that we get customers approaching us on a near daily basis saying, my system was installed in 1970, it's been fine, I get it emptied every year, but I've just found out about these general binding rules. I've had a local contractor out and they said, it's an old system, you need to have it replaced, referencing the 1983 specific line in the rules. Now, occasionally that's true. Maybe it's not performing, maybe there's some structural issues, and maybe it does need replacing. But in default, we can't throw the line of it's before 83, therefore it's got to be replaced, because that is factually wrong. What needs to be done every single time through a company, mine or someone similar, is a check of that pre-1983 system. Let's have a look. If it's a 1970 septic tank discharged into a little Heath Robinson style soakaway in the middle of the garden, okay, it doesn't adhere to current rules, but it doesn't have to. If it's a discharge to ground, it's performing as expected and it's not polluting, then that system does not need to be touched. If at some point in the future it goes wrong, of course it needs to be repaired or replaced using current standards. But as it stands, a 1970 septic tank discharged into ground and it's performing does not need to be touched. On the flip of that, if you've got a 1970 septic tank discharged into a surface water, irrelevant of when it was installed, that is non-compliant. What we also see is lazy contractors saying, it's a pre-83 system, you can do what you want, the rules don't apply. That, again, is simply untrue. The 1983 line is there to say, we want to be fair, and we don't think it's fair to retrospectively apply post-83 rules to pre-83 systems. It just gives the asset and the asset owner a little bit of flexibility where it's not a default, get a new system in the ground. So it's really important to try and age the system, get it checked, and then establish if it's compliant or not. You can't just make a statement based on the age of the system. I know everyone's probably looking at the clock going, hurry up, hurry up, hurry up. This is just quickly what every competent engineer's inspection should look like. You check in the liquid. Ideally, we would have the tank emptied whilst we're on site so we can see how the tank performs as the level drops. You can hear or see if there's any imperfections. We want to check the structure, the T-pieces, the baffles to make sure the protection, the separation is occurring properly. We're going to measure the size to make sure that it's adequately sized for the property it serves. Where accessible, We want to get a conventional CCTV camera kit in the exit pipe work to see if we can find out more information about the discharge, its design, depth, location, functionality, etc., etc. And again, checking for those cross connections. As I said, pretty much a third of all systems we look at have them. They've got to be taken off the system. This is nothing more than a slide to prove to you, because some of you have got not a clue who I am. Very kind of Saventrix to get me involved. We are not an installation contractor by choice. We are impartial and independent, so I'm able to be invited to things like this where you can sit there in confidence that I'm speaking truthfully, because I'm not in any way trying to manipulate and capture work. What we do, a bulk of our work is indeed seller or pre-purchase surveys. We're looking at condition reports, compliance reports. That's our bread and butter. But we're also appointed by the courts, solicitors, insurance companies for you wouldn't believe the range of services that are required just on septic tanks. It surprises me. But more importantly, I would love it for you to use me as your free, and my company as your free resource. About a third of my time every single day, including weekends, I get emails, calls, and messages through LinkedIn from property professionals saying, I've received this quote. Does it look reasonable to you? I've had this drainage questionnaire filled in. I'm not really sure. Is the customer confused? Am I confused? There's an interpretation of the rules that's confused me. And people are just using me as a free sound check, as a sounding board. And I would rather we have a 5-10 minute exchange and make sure that clarity is achieved for your situation or your client than someone taking a bit of a punt and a mistake happening. So please use and abuse. I know through Saventrix we've created a guide, the checklist, the drainage questionnaire. I can send this all to everyone. It's all free. It's to be circulated to your peers, to your teams, to your clients, just so everyone has a degree and a base knowledge to just minimize the chance of a non-compliant system continuing to discharge non-compliantly, or more specifically, through a property transaction, we don't allow any to slip through the net. So use and abuse. It's what we're here for. I absolutely love it. All I've ever done. So if I can help in any way, I don't need to be formally instructed to give advice, and just, like I say, just bounce off me. It's what I'm here for. And I'm bored of my own voice, so I think that's enough. Thank you ever so much for giving me your time. I know everyone's extremely busy. It's the end of the day. It's hard to concentrate, but thank you ever so much. I will stop sharing my screen. I'll give it back to Ryan. If there are any questions, fire them at me. I'm here for you. There we go,
Thank
Ryan.
you, James. Thank you very much for that. I'm just going to share my screen. Has anybody got any questions? If you have, just pop them in the chat. I can see we've got a couple at the minute coming in. Ian Hughes, you're still there. Would you mind just reading those questions out, and I'll keep my screen on here. And then if anybody's got any others, just pop them in.
Was that, are we nationwide for surveys? Yes, we are. We do all the initial surveys ourselves because I trust my engineers more than anyone. And then we have 107 installer partners around us. So we've got full UK coverage for surveys and installations. But to be crystal clear, the installation partners are that. They are separate limited companies that are effectively qualified by our team here, but we are separate entities. I do the introduction, I can babysit a situation, but they are separate installation companies. We are the upfront surveyors and consultants.
Any further ones in the chat, James, for you to run through, if you can see them?
I can't see any more questions. I'm sorry.
Perfect. Yeah, if anyone has any more, then like I said, either feel free to unmute yourself and let us know now, or pop them in the chat. In the meantime, just while you get a chance to do that, I'll just run through the upcoming webinars we've got. So we've got one with Lionheart coming up on the 24th of February, all about the surveyor wellbeing and what needs to be in your wellbeing toolkit. So more information will be on LinkedIn and coming out through our social media channels and email on that one soon. And then our friends at Best Training have also got one coming up on the 25th of February, talking about investigating moisture in traditional buildings. I know Ian Bullock and Stephen, I think, have both joined the call. So again, if anyone's got any questions about that, I'm sure they wouldn't mind answering on either of those. So yeah, thank you very much for coming. Is there any more questions come through? Are we all good? All good.
Yes, we got one question
Okay.
from Craig. Does brick acid destroy the off mains environment like bleach does?
Acids and bleaches will hinder the treatment process. So in default, yes. So without being ridiculously graphic or simplistic, since day one of my 28 years in this industry, I've always been taught that only the three P's should go into any off-main system, which is pee, poo, and paper. Anything else should be dealt with separately. Not always easy to do, but any bleaches, detergents will destroy the good bugs, the microorganisms that either grow in the plant or grow underground in the soakways. So wherever possible, stop any of that entering the system.
Super. Any other questions for James? Feel free to mention Mike. Gravel pits okay for a soakaway?
If it's installed pre-83 and it's working, yes. Modern day, the only soakaway for a septic tank is a drainage field, so it's a piped solution. And you can't even have a gravel soakaway for a sewage treatment plant. There's a myriad of different options, but not a gravel soakaway. So I'm afraid not. If one has gone in, it needs to be signed off by a building control officer, and there's got to be a very good explanation as to why that has been sanctioned, because it's not in any regs as acceptable.
Thank you.
If anyone wants to ask questions outside of this, if people are busy or they think of a question later tonight, feel free to link with me on LinkedIn and go through the direct messaging. That's how most people get hold of me. So yeah, as I say, use and abuse any question at any time of night. Just fire it over and I'll get a response to you as soon as possible.
Thank you, Jonathan. Thank you, Chris, for pointing that out. One more then. So we've got, I recently provided a level 2 survey of a detached house built in 2022. This is from Jonathan. The drainage system was of a sewage treatment plant, and the plant was installed in the rear garden less than 2 metres from the boundary. It was over 7 metres from the building. But my question is that I advised the client that it's likely building regulations require the spacing of the tank to be greater than 2 metres due to maintenance, and possibly need to replace the tank without disturbance of the boundary. The weird thing was that building control signed it off as all okay. Was I right to suggest the position is required due to my thoughts or something else? Thank you, Jonathan.
Logically, Jonathan, you're absolutely spot on. That doesn't make a lot of sense. Weirdly, in building regulations, it stipulates a minimum distance of 7 meters for a septic tank from any habitable part of a dwelling, but it doesn't specifically reference treatment plants. So logically, we've just assumed it means the same minimum distance for a sewage treatment plant, as it is effectively a similar sized and made structure. The only reference to boundaries is that the discharge from a tank or a sewage treatment plant shouldn't be within 2 meters of a boundary, but it doesn't reference the asset itself. So what you said makes perfect sense. It shouldn't be physically that close to a boundary. There's nothing in the regs that stops it going that close. As long as it's got that 7 meter minimum distance from any habitable part of a dwelling, then the BCO will sign it off. I imagine there was nowhere else I hope there was nowhere else for it to go, rather than it be a conscious decision to put it there, because that sounds like a bit of a daft location.
Thank you, James. Well, that was super.
Actually, sorry, Ian, can I just ask a quick question of James? Following on from what you've just said, I've seen many small cottages in the middle of the countryside on small sites where there's no way you're going to get 7 meters away from the building. What do you do then?
So what I've seen, if you only need to breach that 7 meters by a small distance, say between 5 and 7 meters, you're typically going to get that signed off. If you're getting closer than 5, what we find, depending on the thoroughness of the appointed building control officer, they might request sacrificial shoring around the excavation to give it extra protection. but that has a massive impact on the cost. So there's lots to consider. It's not always a case of let's see how we can keep the BCO suite. It's like, well, actually, we know it's going to have a negative cost impact and quite substantial as well. So there's always a way. We've never had a site that's beaten us, but the closer you got to go, the more bespoke the solution, you know damn well that's going to increase the price. So it becomes very unattractive very quickly.